What's up, best friends? It's Brian Deach. Today, I want to talk to you about the Zero Trust Factory. And you might be thinking to yourself, how on earth does Zscaler play in this OT space when they're a cloud security company and doing stuff in the factory? It's okay, baby birds. I'll feed you. So let's go in with a oversimplification of a factory floor and say that you have some type of network over here. We'll say that it's VLAN 100. And that's a /24 address. And we're going to have a OT device over here. We'll call it OT1. And then we'll have a OT device number 2. And then last but not least, OT device number 3. And since they're all in this /24 network, they can all talk to each other the way God intended. And doing microsegmentation here is very tricky because you can't install agents and trying to do with a firewall. This is not going to scale or make any sense. But sometimes, or heck, maybe perhaps in the factory of the future, you're going to have these devices actually reaching out to the private cloud, for example. So think Azure, AWS, GCP, ERP systems, or heck, even back over here at the legacy data center. So we'll call it applications A and B for grins. Could be in either or of these statements. In addition to that, you have to think about third-party people coming into your environment and touching these OT devices. And what you do today, you probably do a VPN and a jump host and allow them to do it. You're taking the biggest liability in your life and putting them on the network, which I think is gross and yucky. And when I say third-party, it could be BYOD, it could be grandma's computer. It doesn't really matter. Plethora of information. So if we think about how we've done this in the past, it doesn't scale very well. We're all familiar with the Purdue Model, and I would argue that it's no longer effective, right? Doing stuff at layer 4 with a firewall, IP-based stuff just doesn't make sense. There's limitations when you get to level 3.5 and below. As I already said, VPN's a horrible idea. Jump boxes, putting these people on the network just isn't a great idea. So let's see how Zscaler tackles this in a more modern architectural way. So we'll start off over here at the branch. We'll make your life easy. Remember firewalls and stuff, level 3, 3.5. Us, we're going to come in and say we have a solution in that Purdue model that's going to start at like level 2.5 and up. So kind of first and foremost. So basically anything with an IP address, we got you, baby. I don't want to overwhelm you with too many 3-letter acronyms from Zscaler, so we'll keep it short. We have the Zero Trust branch, Zero Trust factory, our little appliance right here. And what this is going to do via a DHCP helper process is take this network of many at /24 and move it to a /32. And by doing so, that traffic, now the only way we can communicate with each other is to go over here and talk to that device by Zscaler on the network. And I'm not doing Zero Trust East-West microsegmentation just yet. We're building up to it. And I know some of you might be thinking, oh, we don't have DHCP on the factory floor. It's okay. I got scripts. We can help you with those statically configured environments. So we'll take a moment here and at least throw one 3-letter acronym your way. And that's going to be the Zero Trust Exchange. You should all be familiar with it. And what's going to happen right here is it's almost impossible to build the policy on box right here. So we're going to send telemetry data about this environment to the Zero Trust Exchange. And by doing so, we're going to leverage the power of our cloud to create the policy. Now, there's often a lot of different things going on, but we'll be able to determine, like, hey, based off the traffic patterns that we're observing, the protocols that we know, that maybe OT device number 1 and talk to OT device number 3. It can do so over Modbus, which is TCP port 502. Correct me if I'm wrong in the comments. And then maybe you have OT device 2, could also talk to OT device 3. And that one's going to do that over, I don't know, BACnet. And that's TCP port 47808. And maybe in your environment, there's never going to be a reason why there should be any NetBIOS communications there. I know that maybe some of your factory stuff does, but in this scenario, I'm going to use that. And we'll say, well, that would never allow any TCP, UDP type of traffic, 137, 135. I know I wrote that backwards, but you know what? You're not my real dad or mom, so I can do whatever I want. We're going to create this policy here in the Zero Trust Exchange. We're going to push it down right here, and then we're going to sit in observation mode. So I'm not going to block anything right off the bat, but let me tell you, while we're doing this observation, 9 times out of 10, if I see traffic that doesn't match the policy that we've created, it's going to be malicious. And so we can be able to have confidence that when we turn it on, we allow the good, block the bad. Furthermore, to add, some sexiness to the solution, we have the ability to come over here and deploy decoys on the network as well, and look for those anonymous type of communications that shouldn't be coming through. And so then we'll say, hey, we have a decoy over here, and yet maybe another decoy over here as well. So that's kind of step one. Do the east-west microsegmentation, call it a day, throw out the decoys to capture any other type of traffic in case someone like silos like a USB drive and does bad things. But I can also do the north-south. Let's say one of these OT devices has to come back over here and talk to ERP or application A and B back at the private cloud data center. Historically, you would do that with underlying technology like MPLS or SD-WAN, all predicated on implicit trust. I think that's gross and yucky. We don't do that. We just want to say that this is untrusted, and this is untrusted, and this is untrusted. And for those of you familiar with Zscaler Private Access, that's that same logic, right? We have that app connector that's deployed internally. You can talk to those internal applications wherever it's at. And it doesn't sit there and wait for traffic to come in. It reaches outbound to the Zero Trust Exchange. And it could allow maybe OT device 3 to come back over here, Zero Trust Exchange, microton over here, and talk to applications A and B, depending what you have going on. In addition, you have third-party contractors. What are they doing? They're doing VPN, jump hosts, gross, yucky. I most certainly don't like it. And so now they can come over here via any modern browser. You get loaded up, Chrome, Firefox. We're going to force identity, get these users to log in, and then based upon who they are, they're going to get some icons on the screen to the things that maybe they can talk to. And yes, I know that you're saying, Brian, it's a web browser. It's this web stuff, but it is more than that. And it's web, it can be RDP, SSH, VNC, real VNC. But again, that traffic always comes here to the Zero Trust Exchange. And then based upon the identity of the user, they can talk. And for those of you that are familiar with, again, the Zscaler private access terminology, this thing works the exact same way as that application connector. It can talk back here to these applications without putting that user onto the network. Give them secure access to it, and then we'll turn it up, right? We'll know exactly who the user is. Do session recording, session proctoring, session ushering. I can do sandboxing, and last but not least, this user, instead of having the ability to know or even log into this OT device, we can do a credential vault and inject those credentials. And it's never a good video without a but wait, there's more type of moment. And so let's come over here and say, we can't forget about field OT devices. So maybe you are in the industry where you're selling some stuff, and so you have this device you're selling out to your customers. It's doing things, has sensors, it's collecting things. How do you do that? Do you connect it to Wi-Fi, right? But there's more of an appropriate way, and this is with the Zscaler SIM solution. And let's do zSIM. So that could either be a physical or an eSIM, and it gets plugged into the device, and it will transparently take all traffic back here to the Zero Trust Exchange for inspection. So that OT device needed to talk to over here, over here, over here, can make that happen, right? If you, as an employee, need to come in and troubleshoot this device, it can actually do both ways on that. So you're going to allow one of your corporate employees with an essential device to come in and be able to safely access this remote field device without putting the user in the network, not having to worry about connecting just any network, anywhere in the world, this thing will be able to communicate. So to sum it up, the Zero Trust Factory, the branch of the future, or I'm sorry, the Zero Trust Factory, the factory of the future is taking your old networks, moving them to a network of one, starting at levels, that Purdue Model levels up 2.5 and above, do true east-west microsegmentation, taking the guesswork out of it, leveraging the Zero Trust Exchange to create that policy and then push it down here for enforcement. Allow these devices to communicate back over here to the private cloud and data center. And then for peace of mind, you can deploy decoys on-prem in case someone silos something with the USB, and allow that privileged remote access for those third-party contractors that are coming in based upon their identity to give them access to the OT floor without putting them onto the network. No agent needed. And last but not least, your field devices that are OT-based. You have the Zscaler SIM solution, whether it's a physical SIM or an eSIM, to take all the traffic that is on the device and send it directly to the Zero Trust Exchange. That's my time, folks. Thank you for watching. Do me a favor, like, comment, subscribe. I have no idea what the kids say anymore these days, but I appreciate you for watching. Have a great day.